Dear friends, as I had discussed in my earlier lecture regarding the different type of the superimposed fault. Now, today I will discuss about the fault. Fault is a planar structure which are developed in the all variety of the rock, sedimentary, igneous and metamorphic rock. It is a fracture or the rupture or the joint in a rock along which the displacement or the movement takes place, then we call it is a fault. If there is no movement at all, means a fracture or the joint which are developed in a rock without any displacement, it cannot be called the fault. For the fault, there must be a movement of the block, either right hand block or the left hand block has moved upward and downward, then we call it is faulting. So, the faulting is a planar structures we found in all variety of rocks, sedimentary, igneous and metamorphic rocks. Now, coming to the elements of faults, the element of fault when the fault plane which is exposed on the horizontal surface, it is called as fault line. So, this line will be called as the fault line, or it is also called as the strike of the fault. And the angle inclination of the fault plane, dip of the inclination, this angle is measured as the amount of dip of the fault plane. This amount of dip of the fault plane, it may be on the right hand side or it may be on the left hand side. So, we call it is the amount of dip of the fault plane. So, we have the fault line, we have the strike of the fault, we have the amount of dip of the fault plane and the angle measured from vertical line to the inclination surface, that is called as head of the fault. So, these are the important elements of the fault. Then the faulted block, the block which has moved downward along the fault plane, that is called as hanging wall. The block which has moved upward as compared to the other block, this block has moved upward, we will call it is the footwall side or the upthrow side. So, there are the two terms is being used, hanging wall and footwall. Footwall, the block which moved upward, and hanging wall, the block which moved downward is called as hanging wall, and the block which moved upward is called footwall side. Now, upthrow side and downthrow side, these are the two different terms are also used synonymously with the upthrow side and downthrow side. The block which move upward is called upthrow side, the block which move downward is called as downthrow side. So, the upthrow side and downthrow side, hanging wall side and footwall side, these are the different terms we use in structural geology. Now, in the case of the fault, when the movement of the block which took place either right hand side or on the left hand side of the block, one block is stationary, another block is moved downward, then we will call it is a normal fault. The hanging wall which has moved downward, then we will call it is a hanging wall. And other words, we can call it the, as compared to the hanging wall, the footwall has moved upward. Footwall has moved upward, then we will call it is the normal fault. Now, there is another term is used, reverse fault. Reverse fault is a term in which the movement of the block takes place in opposite direction. In the normal fault, hanging wall going downward. In the reverse fault, hanging wall is moving upward. When the hanging wall is moving upward, then it is called as reverse fault. This movement of the hanging wall, in place of going downside, it is moving upward as compared to the footwall, then it is called as the reverse fault. Now, the different type of the faults are, first I will tell you how the movement takes place in the fault. In the fault, the movement takes place in the vertical movement, horizontal movement and the inclined movement. The horizontal movement, the faulted block moves in these directions, horizontally like this. Vertical direction, the movement takes place vertically at the angle of 90 degree, this way or this way, then we call it is vertical faults. Horizontal fault, or it is called a transverse fault, when the movement takes place in the horizontal directions, horizontal movement takes place. And third one is the oblique or inclined movement of the faulted block at an angle ranging from 0 to 90 degree, then we will call it is the inclined fault. This faulted block is moved along the fault plane at a different angle, then we will call it is the inclined movement of the faulted block. Means the three movement takes important in this fault, that the horizontal movement, vertical movement and the inclined movement of the faulted block, or along the fault plane, the three important movement takes place, then we define it three different type of the fault. We call it horizontal movement of the block, vertical movement of the block and inclined movement of the block, whether the movement has taken place in the right hand side of the observer or in the left hand side of the observer. So, we define it the three different type of the movement of the faulted block. Now, before I go to the different type of the faults, I will tell you a very important thing, the effect of fault on the strata. effect of fault on the strata means there are 3 different types of the strata. Strata which are horizontal, which amount of dip is 0 to 5 degree, we call it is the horizontal strata. The amount of dip of the strata is 85 to 90 degree, it is called as vertical strata. And the dip of the fault plane, dip of the strata which is ranging from 5 degree to 85 degree, they are called as inclined strata. So, the effect of fault on this horizontal strata, when the blocks move upward and the upthrow side is eroded away by the process of geological process, by weathering and erosion, upthrow side will be eroded away, and the older rock of the upthrow side will come into contact with younger rocks of the downthrow side or hanging wall side. So, the line of the contact between the older rock and younger rock can be marked as a fault line on the eroded surface. So, here in this horizontal strata there is a omission. Whatever the strata was deposited on the upthrow side, it is be eroded away, directly the older rock coming in contact with younger rock. So, we call it there is a omission of a strata. This is one possibility. Then in the case of vertical strata, when the movement takes place along inclined fault or the vertical fault, when the, and then upthrow side when the erosion takes place, then there is here we are getting repetition of structure is occurring, repetition of strata is occurring in it. Now, in case of a dip of the fault plane, when the dip of the fault plane and the dip of the strata is in the same directions, say on the right hand side or on the left hand side. So, on these conditions, by the faulted block which has moved upward and hanging wall has gone downward. So, hanging wall side will be again eroded away, and by the geological process, weathering and erosion, this mass will be eroded away. So, here also we get that there is a repetition of strata. Repetition of strata means ABC, ABC, ABC type of the repetition will occur, or numerically we can call it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So, this type of the repetition is commonly seen in the vertical strata as well as in inclined strata, whether the fault is on the right hand side or on the left hand side. This is a broad classification for the fault. If the movement of faulted block on the right hand side of the observer, then we call it as right handed fault. If it the movement of the block hanging while moving on the left hand side of the observer, we call it is left handed fault, normal fault, left hand right handed normal fault. So, these are the terms we are using: right handed fault and left handed fault, right handed normal fault, left handed normal fault, right handed reverse fault, left handed reverse fault, depending upon the movement of the faulted block and on the from the observer side. If the observer's right hand side movement, then we will call it is it is right handed normal fault or the right handed reverse fault. If the movement is on the left hand side, in case of normal fault, we will call it left handed normal fault. If the movement of the reverse fault is, then we will call it is left handed reverse fault. So, these are the different type of the faults we get in the faults. Depending upon the movement of the block, either on the right hand side or the left hand side, we can define the different type of the normal fault and the reverse fault. Now, coming to different type of the faults. Different type of fault means first fault is a parallel fault. When the fault plane, they are parallel to each other. Fault plane, their strike and their fault plane, they are parallel to each other irrespective of the movement of the block. Those faults are called the parallel faults. And another fault is a step fault. A step fault is a type of fault in which the movement of the block takes place. One block is upthrow side and rest block is continuously going down and down and down, or either on the right hand side or on the left hand side. We call it is a step fault. A step fault means what we use it to go to the first floor. We are using different type of the ladders are there. So, the ladder shape of the fault we are getting in the sedimentary rocks and in the metamorphic rocks. So, we call it is a step faulting. Right. So, step faulting, there are the two type again of the right hand side, right handed step faults and the left handed step faults. So, these are the two different type of the step faults are there: parallel fault, step fault. Then there is radial fault. Radial fault means their strike is radiating from center point in the different direction. Radial fault in which the strike directions of different faults are radiating from center point to the periphery, we call it is a radial fault. Then there is a peripheral fault or peripheral fault. This is a type of fault in which the fault plane is not straight. Here the fault plane is in curvature. Fault plane is in curvature and there is a movement takes place on the depending upon the movement direction, right hand side or left hand side. So, the fault plane is not straight, it is a curvature. This type of the curvature of the fault plane is, so this is called peripheral fault. So, we are having the fault, parallel fault, we are having a step fault, we are having radial fault, we are having peripheral fault. Then if the fault is parallel to dip of the stator, then we will call it as dip slip fault. If the fault movement direction is parallel to strike of the fault, we call it is strike fault, right. And diagonal fault is a fault which is oblique to strike and oblique to the dip directions. So, these are the three different terminologies used by structural geologists, depending upon if the strike of the fault is parallel to the movement directions, number one. Number two is the amount of dip is in the same direction of the fault plane, dip of the fault plane and dip of the stator is in the same direction, we will call it a dip slip fault. And if it is oblique to strike direction and oblique to dip direction, then that fault is called inclined fault, or it is called as oblique fault. So, these are the different type of the faults we get in structural geology found in sedimentary, igneous and metamorphic rocks. When we are calling the bedding fault it is always occurring in sedimentary as well as in metamorphic rock. In the igneous rocks we do not get bedding fault, we do not get a strike fault, because in the igneous rock we do not get the strike direction, we do not get the dip direction of the igneous rock. Only in sedimentary and metamorphic rocks we get this variety of the fault: strike slip fault, strike fault, dip fault and diagonal or inclined faults. Now, there is another group of structural geologists, they are using slip fault, strike slip fault. When the movement direction is in the strike direction of the stator, then we will call it as strike slip fault. When the movement of faulted block is in the dip direction, then we will call it as dip fault, or if it is opposite to the dip of the stator, then we will call again the fault plane which are oblique or which are inclined fault. So, these are the different type of the fault. We are with different type of the terms we are using in structural geology for defining different type of the faults. Now, I am coming to the next important thing is classification, because when we are getting number of structures are there, then we have to classify them into different categories. Now, in the fault chapter we can classify the fault into two different categories based on genesis, and another one is on geometrical classifications. In the chapter of the faults, the element of fault, it is better to understand what are the different functions we are going to use it in the measurement of the fault. Now, the fault plane which is intersecting on the horizontal surface, and the horizontal surface where you get a straight line of the fault, it is called as fault line. Now, the exposure of any inclined surface on the horizontal surface is called as the strike of that particular structure. If there is a simple strata is there, so this line will be called as the strike of that particular strata. If the fault plane is exposed, so this line will be called as strike of the fault. Now, this plane which is inclined, when we are measuring with the horizontal surface, so this angle will be called as amount of dip of the fault plane. It is on the right hand side. If it is on the left hand side like this, then we will measure it like this. So, this will be called as amount of dip of the fault plane, and its direction we will have to record it with respect to the full circle measurement on the instrument clinometer compass or the Brunton compass. Now, depending upon the amount of dip of the fault, as I told you, there are the three different types of the movement: horizontal movement of the faulted block, vertical movement of faulted block, and the inclined movement on the right hand side or on the left hand side of the movement of the hanging wall side. We call three different types of the faults are. Now, depending upon the amount of dip of the fault, we can easily classify the three category: low angle fault, LAF. In short, we can write it LAF, low angle normal fault, LANF. Low angle normal fault is ranging from 0 degree to 30 degree, is called low angle fault. Medium angle is called 30 to 60 degree, and 60 to 90 degree dip of the fault plane is called as high angle fault. So, we are using LAF, MAF and HAF, and now depending upon if we are using this term LAF for normal fault, we will write it LANF, low angle normal fault, medium angle normal fault, high angle normal fault. Now, if we are using this terminology for the reverse fault, in which the hanging wall, in place of going downward, it has moved upward, then we will call it as the reverse fault. So, in the case of the reverse fault also, we are using low angle reverse fault, we are using medium angle reverse fault and the high angle reverse fault. Now, these are the terminology: low angle, medium angle, high angle we are using for a simplified terminology of the faults depending upon the amount of dip of the fault plane. So, we call it low angle, medium angle and high angle faults. Now, coming to classification of the faults, as I told you, there are the two different types of classification is used. One classification is called geometrical classification and another classification is called genetic classification and geometrical classification. Genetic classification means how the relative movement of the faulted block takes place. One block is stressing, another block is moved downward or upward is called the genetic classifications, where we are using the term relative movement of the faulted block. Now, another classification is geometrical classification of the fault. The geometrical classification of the fault is purely on the geometry of the fault plane, how the amount of dip of the fault plane is, how its strike direction, how is its head. So, depending on the different parameters, the classification of the fault is number 1, depending upon the based on the wreck of the net slip. The type will be called type of the fault will be called strike slip fault. A strike slip fault, that fault one end in which the net slip is parallel to the strike of the fault, that is the strikes equals to the net slip and the dip slip is 0. The net slip is also thereof the 0. The second type of the fault is dip slip fault. The dip slip fault is a fault is one in which the net slip is up or down to the dip of the fault. The dip slip fault, dip slip equals the net slip and there is no strike slip component. The wreck of the net slip is the image. The third one is diagonal fault, diagonal slip fault. A diagonal slip fault is a one in which the net slip is diagonally up or down the fault plane. The wreck of the net slip is greater than the 0 and less than the 90 degree. Then the second, there is a second classification which is based on attitude of the fault relative to adjacent rock. The type of the fault will be strike fault is a fault one that essentially strikes parallel to the strike of the adjacent rock. The strike is ordinarily measured on the bedding, but in the bedding it is absent. The strike may be measured on the schistosity or the metamorphic rocks or on the flow structure of the igneous rock. Then there is another fault is the bedding fault. Bedding fault is a fault in which it is the displacement taking place parallel to the strike of the bedding plane, and then there is another fault is the dip fault. Dip fault, it is the strike essentially parallel to the direction of the dip of the adjacent bed. Then the next one is the oblique or diagonal fault is one that strikes obliquely or diagonally to the strike of the adjacent rock. There is another term is being used, longitudinal fault. The longitudinal fault strikes parallel to the regional structures as it is exposed. And the transverse fault, that the strike is perpendicular to the strike of the regional structure, as in the case of a dip fault, The third important classification which is based on the fault pattern, and this classification is how the faults are exposed on the ground. We are calling them the pattern of the fault, or ground or on the map. So, we call it is pattern of the fault. Now, we have different variety of the faults are the parallel faults. It is in some localities the strike of the fault plane is parallel to the strike of the strata. So, we call it is parallel faults, and the parallel faults is a fault in which the fault planes are always parallel irrespective of the movement of the block. Then there is another fault is anaclon fault. Anaclon fault, these faults are relatively short fault or a small faults that overlaps each other. Then there is another fault is peripheral fault. The peripheral fault, it is the in place of straight fault line, it is having the curvature on the fault line. So, it is called a circular fault or exposed in the hilly areas. Then there is another term we are using it, the radial fault. Radial fault is the strike direction of the faults are oriented from the center point in different direction. So, it is called as radial fault irrespective of the movement of the block, up throw side and down throw side of the different block. Then coming to the fourth classification, which is based on the amount of dip of the fault plane. The high angle fault, the fault plane which angle is, amount of dip of the fault plane is more than 45 degree, we will call it is high angle fault, and the amount of dip of the fault plane is less than 45 degree, we will call it is the low angle fault. So, the high angle fault and the low angle fault, this is a very important classification used for the classification on the regional scale. Then there is another fifth classification which is based on the apparent movement of the block. The apparent movement of the block means up throw side and down throw side. In case of the normal fault, in one in which the hanging wall is vertical section at the right angles to the strike of the fault appears to have gone down relative to the footwall, and the apparent thrust fault is the one in which the hanging wall is a vertical section and right angles to the strike direction of the fault appears to have given up relative to the footwall. Amount of dip is less than 10 degree. It is called a thrust fault. It is a type of a reverse fault or the low angle reverse fault. Then there is another fault is the reverse fault. A reverse fault is a fault in which the hanging wall, in place of going downward, it is moving upward. So, it is called as the reverse fault. In normal fault, it moves downward, hanging wall moves downward, and reverse fault, the hanging wall, in place of going downward, it is moving upward. So, we call it is the reverse fault. Then there is another classification, a genetic classification of the fault. It is based on the relative movement of the faulted block. Now, the normal fault is a fault in which there is a hanging wall is moving downward either on the right hand side or on the left hand side of the observer. So, we call it is the normal fault. We can call it right handed normal fault because if the hanging wall is moving on the right hand side of the observer. If the hanging wall is moving on the left hand of the observer, then we will call it is left handed normal fault. As I already told you, right handed normal fault and left handed normal fault. Then there is another term, the thrust fault is a fault that which hanging wall has moved upward as relative to the footwall. It is just move upward, and it is a type of low angle reverse fault, and it is very easy to recognize in the field. In the Himalayan region, it is very common to see it. Now, the reverse fault is a thrust fault that dips is more than 45 degree, we will call it is the reverse fault, or the overthrust. Overthrust is a term we are using it for the angle of dip is more than 10 degree, and the right handed normal fault, and the left handed normal fault. These are the different terminology we are using depending upon the movement of the relative hanging wall side on the right hand side or the left hand side of the observer. So, we call it is the left handed normal fault and the right handed normal fault. Now, the another term we are using it under thrust. Under thrust, the rock which is thrusted under the younger rock coming under the older rock, then we will call it is the thrust fault. And there is another term we are using, detach. Detached fault is a special category of the low angle normal faults due to downhill sliding of the rock from an uplifting regions. And then there is another fault is a strike slip fault is a fault, or the wrench fault, or those along with the displacement has been taken place essentially parallel to the strike of the fault, and strike of the fault. Dip slip fault component is the small than the strike slip component. Now, the right slip fault is one in which the opposite wall move relatively to the right hands, and the left slip fault is one in which the opposite wall is moved relatively to the left side, and the left lateral fault, the movement of the faulted block is in the left side to the observer. Right lateral movement fault is one in which the movement of the faulted block is in the right side of the observer. The dextral fault, this is another term is been used, dextral and sinistral. Dextral fault is the right-handed right lateral fault, or the sense of the displacement in the strike slip fault zone, where one block is displaced to the right of the block which the observation is made. Then there is another fault is dextral fault. Dextral fault is a right-handed normal fault, and the sense of the displacement in the strike slip fault zones where one block is displaced to the right hand of the block which the one observation is made. Then there is another is a sinistral fault. Sinistral fault is a left-handed left lateral fault. The sense of displacement is in the strike slip fault zones, where one block is displaced to the left of the block from which the observation is made. Now, see, in the geometrical classification of the fault, we have discussed about the variety of the faults. The important thing is that we are having the dip slip fault, strike slip fault, diagonal slip faults, and the right-handed fault, and left-handed fault, reverse fault, and normal fault. And there is a special term has been used, sinistral fault and axial fault. Axial fault is a right-handed normal fault or right-handed reverse fault. Sinistral fault is a left-handed. Sinistral fault is a left-handed normal fault and the left-handed reverse fault. So, this all comes under the classification, geometrical classification of the fault. Now, coming to the genetic classification of the fault. Genetic classification means in the faulted block, the relative movement has been taken place. Depending upon the relative movement means there may be a footwall may go up, hanging wall may stationary. Footwall may go up, hanging wall is stationary. Now, another case is footwall is stationary and hanging wall is moving downward or it is moving upward. So, depending upon the movement of another block, hanging wall, if the hanging wall is moving, one block is stationary. So, this is called the genetic classifications. So, we have the relative movement of the block. Relative movement means one block, up throw side is stationary, hanging wall is moving up and down. Hanging wall is stationary, foot wall is moving up and down. So, this is called the genetic classification of the fault. So, the fault is very important to understand the different type of deformations. Now, for the development of the faults, different type of the stress conditions are responsible for the development of the fault. Now, at the time of the development of the fault, the three axes of the stress ellipsoid, we have the greatest principal stress axis, intermediate principal axis, and least principal stress axis. It has been represented by epsilon, symbol of epsilon 1 is a GPSA, greatest principal stress axis, epsilon 2 it is a medium principal stress axis, and LPSA is represented by epsilon c. So, these are the three terms has been used. It is occurring in the ellipsoidal shape. The stress ellipsoid is in the ellipsoidal shape, and wherever you are getting the development of different faults are, the longer axis means the GPSA is developed parallel to that particular fault plane, and the rest of the axis LPSA and IPSA may be oblique or inclined, depending upon how the GPSA epsilon 1 axis of the stress ellipsoid is, the faulting may takes place. It may be a normal fault, it may be reverse fault, it may be a thrust fault, it may be a nappe structure also. So, it is very important to understand what the mechanism of the fault is. Now, in the next lecture, I am going to tell you how you are going to recognize the fault in the field and as well as in the lab or in the geological map. Okay? Thank you.